Now let us derive the expression for efficiency of a half-wave rectifier, eta. The efficiency is defined as the ratio of the DC output power to the AC input power of a rectifier. So eta, output whatever we expect is DC and input we give is AC. Therefore output DC power by input AC power, PDC by PAC, where PDC is the DC output power of a rectifier, which is given by PDC is equal to IDC square into RL. But we know that IDC of a half-wave rectifier is Im by pi. Substituting here Im square by pi square into RL. Let us take this here, where PAC is, let us take this is equation 2. This is a 1 and this is equation 2. Now PAC is the input power of a rectifier given by IRM square into RL plus RF, because AC value is present both across the diode, also at the output, because of the pulsating DC. Therefore IRMS of a half-wave rectifier is given by Im by 2. Substituting here we will take this as equation 3. Substitute equation 2 and 3 in equation 1, that is in the formula of eta PDC by PAC. We get this one. Simplifying this one, 4 pi r square by 1 by RL plus RF. If it is an ideal diode, the forward resistance is 0, that is RF is equal to 0. Substituting this RF 0 is equal to 0 in the above equation, we get eta is equal to 4 pi r square, where 4 by pi r square is nothing but 0.405 in terms of percentage into percentage, 40%, 40.52%. That is nothing but for half wave rectifier, out of 100 units given, only 40 of is converted into the output, which is nothing but efficiency as 40.52%. Therefore, the maximum of 40.6% of AC power is converted into DC power. So total, suppose if you are giving 100 units of power as an input, only out of which 40 is converted into DC output, and 60% is, so approximately 60% is get wasted. So now we'll calculate the percentage voltage regulation, which is given by V no load minus V full load by V full load, where V no load is nothing but when load is not connected, what is the voltage across the terminals, that is nothing but V no load. When full load is connected, what is the voltage across this one? So here V no load is the DC output voltage when load current is zero or no load. V full load is the DC output voltage when load current is equal to the load of normal load. The ideally DC output voltage is independent of load current. V no load is equal to V full load. If it is ideal case, so it doesn't depend on the, but percentage regulation in that case will be 0. But practically VDC or VDC to load is equal to Vm by pi into RL by RL plus F. So V load equal to Vm by RL plus RF. Taking RL down, we'll get V no load is equal to Vm by pi. Taking RL as infinity, it is open circuit. Open circuit, load is not there. This is for equation 1 is for load. When we for equation 2, no load, for VDC no load, load is not present. Load is not present in the sense open circuit. Remove the load. Removing the load is RL is equal to infinity. Substituting here we get Vm by pi. Vm by pi. Substitute this equation 1 and 2 in equation 1 and 2 in a Roman number equation 1. Substituting this one, VR voltage regulation is equal to V no load minus V full load by V full load. Substituting that equation 1 and 2, we get Vm by pi, you can take common, 1 minus RL by RL plus RF divided by RL by RL plus RF. Taking LCM, denominator get cancelled, RL plus RF minus RL get cancelled, you get RF by RL into 100. For an ideal diode, voltage regulation is 0, since RF will take as a 0.